auditors, my name is Yisheng. Today we are going to go through the Ethernaut Reentrancy Challenge. I'm going to explain the vulnerability of reentrancy and how do attackers exploit it. So in this reentrance contracts, there are a hash map and 4 functions. So we have the donate, balance off, withdraw, and a receive function to receive Ether. So firstly, the donate function is basically an account can actually donate whatever amount to these particular contracts, and it will be stored here or at this hash map. And then the donator can actually check the amount donated that was stored in these hash maps. And then this is the withdraw function. So what it does is basically can withdraw the amount that was stored here before. So what the problem of this withdraw function, that it is possible and vulnerable to reentrancy attacks. So let me iterate. So firstly, the attacker can choose to specify, for example, 0.01 Ether, and this particular function will check whether the attacker has particularly 0.01 Ether. We do not want anyone to basically have this amount of Ether and then able to withdraw maybe 1 Ether and thus stealing all this particular money in this smart contract. Anyways, as I was saying, you can actually put 0.01 Ether and then the contract checks whether you have 0.01 Ether and then perform this interaction to basically transfer 0.01 Ether to your account. And then lastly, we will update it and update this hash map. So basically this is an effect. Over here we have this particular redundant statement. This is a no operation statement. There's no practical effect, so you can just ignore this. So as I was saying, this particular contract checked, interact, then perform an update or an effect, which this is wrong. The correct way is checked, update, or effect, and then interact. So why is this vulnerable? Is because an attacker can choose to create a fallback function to keep on siphoning this smart contract balance. So how does he do that? It's actually quite simple. In this fallback function, he can always call this particular withdraw function. So for example, when the attacker can call these withdraw functions, and once the attacker receive this particular amount, 0.01, in this fallback function, we will actually call the withdraw function of this contract again, thus performing a recursive loop and siphoning all the particular Ether in this contract until there is none. And then afterwards, the attacker can choose to destroy the contract and then send the remaining Ether to his particular wallet. Okay, now we are at Visual Studio Code. You can see that this is the reentrance contract and this is the interface. And over here we have the attacker contract. So this is a simple constructor. Basically, I deployed a certain amount and stored it here. So as this is a reentrance interface to interact with this particular Solidity contract file. So firstly, what we can do is to perform by calling this function, attack function. So this particular withdraw whatever amount we specified here. But before we do that, we firstly have to donate certain amount here. So that our account will be stored here. So afterwards, we can call this attack function which withdraw the amount here. For example, in our Brownie script, we specify 0.01. So basically, he will send 0.01 Ether to our attacker contract. So once he sent here 0.01, we can actually call the withdraw function again, thus performing a recursive function to siphon all the Ether in this particular reentrance contract. So once this is done, we will call this destroy function so that this particular function will send all the ether to our particular EOA account, which is us, our smart contract wallet. So let's do this by getting a new instance. It's taking quite long. So basically, I'm just going to run the script and I'm gonna skip forward to the end of this particular challenge. Okay, now the Brownie script has run successfully. You can see that in the first place, we have this amount of way in the smart contract address, and then you can see that the attacker contract in the first place has 0 because we actually donated it to our reentrancy contracts, our reentrance contract. And then you can see that afterwards, when we call the attack function, you can see that our attacker address actually is able to siphon off this amount of way. And the reason why over here there is this specified amount is because the blockchain transaction is actually slightly slow to be mined. Thus, sometimes Brownie has this issue, but anyways, there will be no issue. We can just submit the challenge and we should be able to successfully complete this particular challenge. Tada! And this is how you complete Ethernaut Reentrancy Challenge. Hello auditors, if you like what you're watching, please hit the like button and subscribe. Thank you for watching and have a nice day.